quicksort, or it is also known as partition exchange sort. It is based on divide and conquer algorithm. The important steps are: first, select the first element from the array as the key element. Then the second step, select the smallest element than the key element from right side. Our aim is to sort the array in ascending order. Therefore, we have to shift the smallest element into the beginning of the array and shift largest element to the end of array. For that purpose, we select the smallest element than the key value. Select the smallest element than the key element from right side. Okay, select the smallest element from right side of the array. The next step, select largest element than the key element from left side. Okay, now we select two elements, smallest element from right side and a largest element from left side. Okay, then interchange the element. That is, if the index of largest element is greater than index of the smallest element. For example, index of largest element is I. Index of smallest element is j. If I is greater than j, index of largest element is greater than index of smallest element. If I is greater than j, then interchange the key element and the smallest element. Interchange the first element. First element is the key element. Interchange the first element and the smallest element. That is the element we select from right side. Interchange those two elements. Okay. If I is greater than j, if I is greater than j, index of largest element is greater than index of smallest element, then interchange the key element and the element selected from right side, smallest element. Otherwise, interchange the smallest element and the largest element. Interchange the selected two elements. Repeat step 2 to 5 till the array is sorted. This is quicksort algorithm. We need two algorithms to perform quicksort. One is quicksort of p comma q. That is the main algorithm. That is a recursive algorithm. Another algorithm is partition of a comma m comma p. Now we explain the algorithm with an example. First, parameter description. Algorithm quicksort of p comma q. Here there are two parameters, p and q. Sort the elements a of p to a of q, which resides in the global array a of 1 to n. That is a of p to a of q. That may be subtime, that may be a local array, which resides in the global array a of 1 to n. In this example, global array is a of 1 to 10. There are 10 elements. Values of p and q are in between 1 to 10. Global array is a of 1 to 10. We use a tree data structure to explain this algorithm. First, we create the root node. and it contains two values, 1 and 10, that is P and Q. There are two parameters in the quicksort algorithm, P and Q. P is the lower bound, 1, and Q is the upper bound, 10. That is represented in the root node. Then first statement, that is statement number 6. If P less than Q, P less than Q, that means there are more than one element. Here P is equal to 1, first element points to 1, index 1, and Qth element points to 10. Q is greater than P, that means there are more than one element. Problem is large, so we have to divide problem into two subproblems. So there is a function called J. J is equal to partition of A, P, Q plus 1. We have to call the partition function, and that return value is assigned to variable J. Partition of A is the array name. P, now the value of P is 1, and Q plus 1, 11. So we pass three values, array name A, P 1, Q plus 1, 11. That three parameters pass to function partition. Now we execute algorithm partition of A, M, P. Value of M is equal to 1, value of P is equal to 11. Listen to the right part. Partition of A, 1, 11. M is equal to 1, P is equal to 11. And A of 11 is equal to infinity. That is mentioned the end of parameter description. A of P is equal to infinity. A of 11 is equal to infinity. Then assign V is equal to A of M. A of 1 is equal to 15. And initialize I is equal to M. I is equal to 1. J is equal to P. J is equal to 11. Okay, initialization part is completed. Then repeat until loop. First repeat until repeat I is equal to I plus 1. Increment I. New value of I is equal to 2. Until A of I greater than or equal to V. A of I. A of 2. A of 2 is 80. 80 greater than 15. Condition true. So exit from first repeat until. Then second repeat until J is equal to J minus 1. J is equal to 10. A of 10. 8. 8 less than or equal to V. 8 less than or equal to 15. Condition true. So exit from second repeat until. And last, if I less than J. I less than J, condition true. So interchange of A, I, J. Okay, that is here we select the largest element than the key element from left side, that is 80, and its index is I 2. The largest element than the key element from left side and we select the smallest element than the key element from right side. That is 8. Okay, we select two elements, 8 and 80. Smallest element from right side, largest element from left side. Then interchange I, A of I and A of j, A of 2 and A of 10, 80 and 8. That is performed in the interchange of algorithm, A of I comma j, interchange of A comma I comma j. So interchange 8 and 80, that is represented in the second array. And I is not greater, I greater than or equal to j. I is not greater or equal to j. So repeat the process. Then first repeat until I is equal to I plus 1. The current value of I is equal to 2. Then new value of I is equal to 3. Until A of I greater than or equal to V. A of 3. A of 3 20. 20 greater than V. 15. Condition true. So exit from first repeat until. Then we enter to the second repeat until. J is equal to j minus 1. The current value of j is equal to 10. New value of j is equal to 9. A of j, A of 9, 7. A of j less than or equal to V. 9. A of 9. A of 9 is 7. 7 less than 15. So exit from second repeat until. Okay, now we select two elements. The largest element, then the key element from left side, that is 20, A of 3, and the smallest element than the key element from right side, that is A of 9, 7. Okay, then if I less than j, condition true, I less than j, so perform the interchange operation, interchange of A comma I comma j. Interchange is selected two elements, A of I and A of j. Interchange 20 and 7. That is represented in the second array. Now I is not greater. I is not greater or equal to j. So repeat the same process. So we enter into the first repeat until I is equal to I plus 1. I is equal to 4. 3 not greater than 15. I is equal to 4. A of 4, that is 3. 3 is not greater than 15. So repeat the process. I is equal to 5. A of 5 is 40. 40 greater than 15. So condition true. Exit from first repeat until. Now we select the largest element than the key element from left side. That is 40. We select 40. A of 5. Then second repeat until j is equal to j minus 1. The current value of j is equal to 9. J is equal to j minus 1 is equal to 8. A of 8 is 70. A of j less than or equal to v. 70 less than 15. Condition true. sorry, 70 is greater than 15. So repeat the process. J is equal to j minus 1. J is equal to 7. A of 7. A of 7 less than 15. So exit from the second repeat until I less than j. So interchange a of 5 and a of j. A of 5 and a of 7. A of 5 is 40 and a of 7 is 6. So interchange a of 5 and a of 7, 40 and 6, that is represented in the second array. I is not greater or equal to j. I is not greater or equal to j, so repeat the process. Now we enter into the first repeat until. The current value of I is equal to 5. Then new value of I is equal to 6. I is equal to I plus 1. I is equal to 6. Until a of 5 greater than or equal to b. A of 6. A of 6 is 50. 50 greater than 15. So exit from first repeat until. Then j is equal to j minus 1. J is equal to 6. A of 6, 50. 50 not less than 15. So repeat the process. J is equal to 5. A of 5 is 6. 6 less than 15. So exit from second repeat until. Now we select two elements. Smallest element from right side is A of 5, 6. And the selected largest element from left side is 50, 50. I not less than j. If I less than j, there is a condition. I not less than j. I is greater than j. So does not perform any interchange operation and exit from all repeat until loops. So therefore A of m is equal to A of j. A of m is equal to A of j, that is A of 5 is equal to 6. Update the array. Array is updated. A of 1 is equal to 6 and A of 5 is equal to 15. A of 5 is equal to 15. Okay, update two arrays. Okay. That is here I greater than j. Therefore, interchange key value and the selected smallest element from right side. That is interchange 6 and key value 15. Now key value is interchanged. Listen to the array. Key value was 15. All the elements in the left side of 15 is less than 15 and all the elements in the right side of 15 is greater than 15. Elements are not sorted, but there is only one condition. All the elements are less than left side is less than 15 and right part is greater than 15, and partition function return j is 5. Partition function return value of j, that is 5, and it is assigned to the variable j in the main function, quicksort of function. So the value of j in the quicksort of function is 5. That is 5 is the position of the partitioning element. A of 5 divide the array into 2. That is left part is less than a of 5 and right part is greater than a of 5. Then next solve the subproblem. There are two recursive call, quicksort of p comma j minus 1, and the second recursive call is quicksort of j plus 1 comma q. If we call the first recursive call, we go to the left subtree of the tree data structure and we execute second recursive call. We go through second subtree of tree data structure. Now we first execute quicksort of p comma j minus 1, quicksort of p comma 1 comma j minus 1, 1 comma 4. Values are p is equal to 1 and j minus 1 is 4. Quicksort of p comma j minus 1. Okay, 1 comma 4. Now we are in the beginning of a new function, a new quicksort of p comma q function with the value of p is equal to 1 and the value of q is equal to 4. First recursive call. Now here p less than q, 1 less than 4. So divide p into two subproblems. Problem is large, so we divide the problem into two subproblems. J is equal to partition of a comma p comma q plus 1. Partition of a comma 1 comma 5. Call the partitioning of function. We pass a 1 and 5 to the partition of function. Now we go to the partition of function with values a 1 and 5. Partition of a comma 1 comma 5. A of 5 is equal to infinity, m is equal to 1, v is equal to a of m is equal to a of 1 is equal to 6, I is equal to 1 and j is equal to 5. The initialization part is completed. Then we first enter into the first repeat until I is equal to I plus 1, I is equal to 2. That is a of 2 is greater than key value 8 greater than 6. So exit from first repeat until. That is, we select the largest element from left side than the key value. So exit from first repeat until. Then j is equal to j minus 1, j is equal to 4. A of 4 is 3, 3 less than 6. That is, we select a smallest element from right side than the key value. So exit from second repeat until. and I less than j, so perform interchange operation, interchange of a of I and a of j, interchange a of 2 and a of j, 2, 8 and 3, that is represented in the second array. I is not greater or equal to j, so repeat the same process. I is equal to 3. In the first repeat until I is equal to I plus 1. I is equal to 3. A of 3. A of 3 is greater than the key value. That is, we select largest element from left side than the key value. We select 7 from left side. So exit from first repeat until. Then second repeat until j is equal to j minus 1. J is equal to 3. A of 3. A of 3 is 7. 7 is not less than key value. So repeat the process. J is equal to j minus 1. J is equal to 2. A of 2 is 3. 3 is less than key value. So exit from second repeat until. Here I is not less than j, I is greater than j. So interchange operation is not performed in until I greater than or equal to j, I greater than j. So exit from all the repeat until loops. So here we perform a of m is equal to a of j. A of m is a of 1. Is a of m is equal to a of j. A of 1 is equal to 3. Okay. And a of 2 is equal to 6. A of j is equal to v, 6. That is represented in the second array. Update the second array and return j, return value of j, that is return 2. Value returned from partitioning of function is assigned to j, that is new value of j is equal to 2. Then next step, next recursive call, quicksort of p comma j minus 1, quicksort of 1 comma 1, quicksort of 1 comma 1, that is called another function, call the same function. So with the parameters 1 and 1. Now we are in the beginning of a new recursive function with the parameters p and q. Value of p is equal to 1 and the value of q is equal to 1. In the body of the function, if p less than q, that is here p is equal to q, p not less than q, so exit from this recursive call, not enter any statement. So exit from this function and return back to its parent function, that is its parent function is a function with j value is 2, that is here parent functions p value is 1 and its q value is 4 and j is 2, return to that parent. These functions first recursive call is completed. Then we have to execute second recursive call. In the second recursive call, we represent In the tree data structure, we go to the right subtree. Go through the right subtree. That is quicksort of j plus 1 comma q. Quicksort of j plus 1 3 comma 4. Quicksort of j plus 1 comma q is 3 comma 4. Now we are in the beginning of that function with the parameters p and q. That is p is equal to 3 and q is equal to 4. P less than q. 3 less than 4, condition true. So divide p into two subproblems. J is equal to partition of a comma p comma q plus 1. Call the partitioning of function with the parameters a, p is equal to 3, q plus 1, 5. Partition of a comma 3 comma 5. A of 5 is equal to infinity, m is equal to 3, v is equal to a of m is equal to a of 3 is equal to 7. Our new key element is 7. And now value of I is equal to 3, j is equal to 5. We first enter into the first repeat until I is equal to I plus 1. New value of I is equal to 4. That is a of 4. A of 4, 8. 8 is greater than 7. That is, we select the largest element than the key value from left side. That is 8. The largest element than 7 is 8. So except from first repeat until. Then second repeat until j is equal to j minus 1. J is equal to 4. A of 4 is 8. 8 is not less than 7. So repeat the process. J is equal to j minus 1. J is equal to 3. 7 is equal to v. Here condition is a of j less than or equal to v. A of 3, 7 is equal to key element. So exit from second repeat until. And next I greater than j. I greater than j. So exit from all repeat until loops. A of m is equal to 7. A of 3 is equal to 7. That is, there is no change in the process. And return j, return 3. The value returned from partitioning of function is 3. Value of j is 3. And that 3 is assigned to variable j in the quicksort of p comma q function. Now the value of j is equal to 3, value of p is equal to 3, value of q is equal to 4 in that function. Next we execute the first recursive call in that function. There are two recursive calls in that function. We execute first recursive call and go to the left subtree. Quicksort of p comma j minus 1. Quicksort of p comma j minus 1. P comma 2. Now we are in the beginning of a new function with the value of p is equal to 3 and the value of q is equal to 2. The first condition, if p less than q, here p is not less than q, here p is greater, p is equal to 3 and q is equal to 2. So not enter into the body of that function and exit from that function and control return back to its parent function. Now second recursive call of that function is executed, and we go to the right subtree of that node, that is p is equal to 4, q is equal to 4. Now we are in the beginning of that function with value p is equal to 4 and q is equal to 4. Then if condition, if p less than q, p is not less than q, so not enter into the body, so exit from that function and control return back to its parent function with value of j is equal to 3. Then that function is also completed, then control return back to its parent function with j value 2. That functions, all statements are also completed, so control return back to its parent function, that is first function. First function is a function with value j is equal to 5. Then that function's first recursive call is completed, then it execute second recursive call. Second recursive call is quicksort of j plus 1 comma q, j plus 1 comma q, that is 6 comma 10. Call the same function, that is call the same function with p is equal to 6 and q is equal to 10. Now we are in the beginning of that function, new recursive call with value of p is equal to 6, value of q is equal to 10. Then body of first condition, if p less than q, p is less than q, so divide p into two subproblems. J is equal to partition of a comma 6 comma 11, call the partitioning of function. Partition of a comma 6 comma 11, a of 11 is equal to infinity, m is equal to 6, b is equal to a of m is equal to a of 6 is equal to 50, that is 50 is the new key element, 50 is the key element. Then value of I is equal to 6, j is equal to 11. We first enter into the first repeat until I is equal to I plus 1, I is equal to 7. A of 7 is not greater than the key value, that is we have to select the greatest element from left side than the key value. So repeat the process. I is equal to I plus 1, I is equal to 8. 70 is greater than 50, that is we select the largest element than the key value from the left side. We select 70 and exit from first repeat until, then second repeat until j is equal to j minus 1, j is equal to 10. 80 is not less than key value 50, so repeat the process. J is equal to 9, 20 is less than the key value, so exit from that repeat until. Now we select two values, that is 70, that is 70 is greater than the key value, and select 20, 20 is less than key value from the right side. I less than j, here I is less than j, so interchange operation is performed, interchange a of I and a of j, a of 8 and a of 9, that is represented in the last array. Array is updated. I is not greater or equal to j, I is not greater or equal to j. So repeat the process. The current value of I is equal to 8 and j is equal to 9. Then we enter into the first repeat until I is equal to I plus 1, I is equal to 9. 70 is greater than key value 50. So we select that element. So exit from first repeat until. Then j is equal to 8. J minus 1 is equal to 8. A of 8, 20. 20 is less than 50. So exit from second repeat until. And here I greater than j. So not perform any interchange operation. I greater than j. So exit from all repeat until loops. And a of m is equal to 20. A of 6 is equal to 20. And a of j is equal to 50. A of 8 is equal to 50. Okay, that is the array is updated. That is represented in the last array. The key value is interchanged. So we can see that all the elements in the left side of 50 is less than 50 and the right part is greater than 50. Left part of 50 is less than 50 and the right part is greater than 50. Okay, so at last return 8, return j, return 8. Value returned from partitioning of function j is equal to 8 and that 8 is assigned to variable j in the quicksort of p comma q function. The next we have to execute first recursive code for that function quicksort of p comma j minus 1, that is quicksort of p comma 6 comma 7 and go to the left subtree of the node quicksort of 6 comma 7. Now we are in the beginning of a new function with value p is equal to 6, q is equal to 7. Then if condition p less than q, condition true. So divide p into two subproblem. J is equal to partition of a comma p comma q plus 1. Call the partitioning of function a comma 6 comma 8. Call the partitioning of function. Partition of a comma 6 comma 8. A of 8 is equal to infinity, m is equal to 6, v is equal to a of m is equal to a of 6 is equal to 20. And initialize I is equal to 6, j is equal to 8. First we enter into the first repeat until I is equal to I plus 1, I is equal to 7. That is a of 7. A of 7 is greater than the key value. Key value is 20. A of 7 40. 40 is greater than 20. So exit from the first repeat until. Then j is equal to j minus 1. J is equal to 7. 40. A of 7 is equal to 40. 40 is not less than 20. So repeat the process. J is equal to 6. A of j is equal to v. So exit from second repeat until I greater than j. So no interchange operation is performed and exit from all repeat until loops. Now a of m is equal to 20. That is a of 6 equal to 20. A of j equal to 20. That is there is no change is performed. And return j. Return j to the main function. value returned from partition of function is 6, and 6 is assigned to variable in the quicksort algorithm j is equal to 6. Then next execute the first recursive call of that function, that is quicksort of p comma j minus 1, quicksort of 6 comma j minus 1, 6 comma 5, and we go to the left subtree of that node. Now we are in the beginning of that function with value p is equal to 6 and q is equal to 5. The if condition, if p less than q, p is not less than q, so not enter into the body of if and exit from that function, and control return back to its parent function, that is parent function with values j is equal to 6, p is equal to 6, and q is equal to 7. On that function, its first recursive call is executed, then its second recursive call execute, that is quicksort of j plus 1 comma q, quicksort of j plus 1, that is 7 comma 7, call the second recursive call, and in the tree data structure we go to the right subtree. Values are j plus 1, that is 7 comma 7. Now we are in the beginning of a new function with the values p is equal to 7, q is equal to 7. Then if condition, if p less than q, p is not less than q, so not enter into the body of if and exit from that function, that algorithm, and control return back to its parent algorithm. Its parent algorithm is an algorithm with the values j is equal to 6, p is equal to 6, and q is equal to 7. On that algorithm, its all statements are executed, all statements are completed, 2 recursive calls are completed, so its control return back to its parent algorithm. Its parent algorithm is an algorithm with values j is equal to 8, p is equal to 6, and q is equal to 10. Its one recursive call is completed, first recursive call is completed, then next execute second recursive call. Second recursive call is quicksort of j plus 1 comma q, that is quicksort of 9 comma 10, and go to the right subtree of that node, quicksort of 9 comma 10. Now we are in the beginning of a function with values p is equal to 9, q is equal to 10. Then if condition, if p less than q, now p is less than q, 9 less than 10, divide p into two subproblem, that is j is equal to partition of a comma p comma q plus 1, j is equal to partition of a comma 9 comma q plus 1, 11, call the partitioning of function with parameters a, 9 and 11. Partition of a comma 9 comma 11, a of 8 is equal to infinity, m is equal to 9, v is equal to a of m is equal to a of 9 is equal to 70, that is new key value is 70. Then initialize I is equal to 9, j is equal to 11. We enter into the first repeat until I is equal to I plus 1, that is I is equal to 10. A of 10, 80 is greater than 70, that is we select largest element, that key value from left side, that is 80, it is greater than 70, so except from first repeat until. Then j is equal to j minus 1, j is equal to 10, 80, a of 10 is 80, 80 not less than 70, so repeat, j is equal to 9, a of 9 is 70, 70 is equal to key value 70, so exit from second repeat until. I greater than j, so not enter, no interchange operation, there is no interchange operation, and exit from all repeat until. A of m is equal to 70, a of j is equal to 70, that is there is no change in the array, and return j, return 9, value returned from partitioning of function is 9, that 9 is assigned into variable j in the quicksort of algorithm, that is j is equal to 9, p is equal to 9, and q is equal to 10. Next we have to execute two recursive code. First we execute the first recursive code, quicksort of p comma j minus 1, and go to the left subtree of the node. Quicksort of p comma 9 comma j minus 1, go to the left subtree, and values are 9 and 8. Now we are in the beginning of function with values p is equal to 9, q is equal to 8, and if condition, if p less than q, p is not less than q, so not enter into the body of if, and exit from that algorithm, and control return back to its parent algorithm. Parent algorithm is an algorithm with values p is equal to 9, q is equal to 10, and j is equal to 9. Its first recursive code is completed. Then next execute the second recursive code. Second recursive code is quicksort of j plus 1 comma q, that is 10 comma 10, and go to the right subtree of tree data structure, that is quicksort of 10 comma 10, values are 10 comma 10. Now we are in the beginning of a new function with values p is equal to 10, q is equal to 10, and if condition, if p less than q, p is not less than q, so not enter into the body of if, and that function exit from that function, and control return back to its parent. Its parent is what is with p is equal to 9, q is equal to 10, and j is equal to 9. That functions, all statements are executed. Control return back to its parent. Parent is j is equal to 8, 6, p is equal to 6, and q is equal to 10. That functions, all statements are executed. So control return back to its parent. Parent is a function with values j is equal to 5, p is equal to 1, and q is equal to 10. That is all recursive algorithms are completed, and now the array is sorted, and all statements of all algorithms are completed. So algorithm is completed.